And so I think we ended up here in the last class. So that's a picture of what a typical Java class looks like. So at the top, at the start of the class, there may be a package declaration. Next are whatever import statements are required. So if the class that you're implementing needs to import or needs the facilities of a class from another package, you require an import statement. I guess one thing regarding the import statement that I haven't told you about yet. If a class is in java.lang, you don't have to import that class. So classes like string and math do not need to be imported. Anything in java.lang automatically is imported by the compiler. It's not an error if you do import them. It's just not necessary. After your import statements, in a typical class, you have your class declaration. And inside the class itself, you have variables or fields. You have constructors, and you have methods. And it's much more complicated than this when you start to look at the more advanced features of the Java language. Right? Eventually, we'll see classes within classes, but everything else that's on that list, we're probably not going to use at all. Okay, so packages. Packages in Java are simply used to organize your classes into what are called namespaces. If you look in your Eclipse workspace, so when you make a package, every time you make a package, you'll see that there's a folder or directory created by Eclipse. If you make a package inside that package, you get a folder or a directory created inside of that folder, and so on and so on and so on. And so really, you can think of packages as a mechanism for organizing the files that belong to your program. Right? Each package has its own folder. Right? Packages inside of other packages are folders inside of other folders, and so on and so on and so forth. Right? So this thing, namespace, this word namespace, a namespace is just a container for names. Right? So every folder has a name. Right? Every directory on your computer has a name. Right? If you put a directory inside of a directory, or a folder inside of a folder, that folder also has a name, right? So folders can contain other folders, right? A namespace can, or a space for names can contain other names. That's all that means. And so the reason you might want to do this is because you probably want to organize your classes that are related to one another into one place, right? Into one location on your, into one folder somewhere. This is especially true if your program consists of many, many, many files, right? So if you have 1,000 Java files, right, you don't want to put them all in one folder, right? Just scrolling through that folder to find the individual files would be very time-consuming. And so you want to organize your files into some sort of, usually some sort of hierarchy or some sort of organization. And so the Java standard library classes, they all go into the package called Java, which makes sense, right? The standard library classes should go into some named package. Java is a sensible name. Okay. So a package is allowed to contain other packages. So the Java package, for example, contains packages named lang and util and io and things like that. Right? So lang is the package where the classes that are considered absolutely fundamental to the language go. So string is in there, math is in there. A few other classes are in there. Util is short for utility, so the useful classes, or the classes that are useful to many types of programs, go into util. So those would be things like your lists and other collections. I/O deals with input and output, right? So reading and writing stuff from a file, from or to a file, from or to a network, and things like that go into the package I/O. Right? So if you have a package inside of a package, the full name of the package is the list of all packages leading up to the package, separated by periods. Right? So lang is inside of Java, so the full name of the package lang is java.lang. Right? Util is inside Java, so the full package name of util is java.util, and so on and so on and so forth. Right? And so the full package name is called the fully qualified name. Right? Now inside of a package, you can place a class. Right? So inside the lang package are the classes object, string, and math, and so on. Right? If you want the full name of a class, you take your full package name, put it in front of the class, and separate everything with a period to get java.lang.object, or java.lang.string, or java.lang.math. Now, the reason you want to do this is because you want to make sure that every class or everything in your program has a unique name, right? So imagine trying to use two classes, both called string, right? The compiler won't know which string class it should be using. Right? The fully qualified class name fully qualified class names are supposed to be unique. And that allows the compiler to figure out which class do you mean when you use two classes with the same name in a program, right? One of the classes uses the fully qualified name, and the other class, like string, can use a shortened name, right? So for example, the standard string would just be big S string, right, which you can use like that. In the same program, if you have your own string class that you want to use for some reason, well, you can use that string class as well, right? You just make sure that you use the fully qualified class name. So if your string class is in the package your, then you can use your.string and string in the same program, right? Now the problem with package names is that you can name a package whatever you want. So there's no guarantee that whatever name you give to a package that you create is different than the packages created by someone else. And so Java uses what's called a package naming convention. So the idea is that your packages should all start with your domain name in reverse, right? So your domain name is your internet name, right? So the domain name of the computing science department is cs.queensu.ca. So if you're following the Java package naming convention, and if you work in the computing science department, all of your packages would start with ca.queensu.cs. Right? And if you're looking at the source code that came with the course, if you downloaded that and imported it into Eclipse, you'll see that all of the packages have these very long package names that start with ca.queensu.cs. Right? Domain names are guaranteed to be unique because there's one central registry for the entire world that manages domain names. Right? So they make sure that there's no two entities with the same domain name. Right? Now, again, there's nothing stopping you from not using this convention. Right? And so if you don't use this convention, then there's no guarantee that your classes will be, the names of your classes and packages will be unique if you need to use somebody else's packages and classes as well. All right, so package is basically a way to organize the files, the source code files in your program. Right? They are one form of modularity in the Java programming language. All right, so once you've got your packages settled out, or sorted out, you can start to implement a class. Right? And so a class is simply an implementation of a type, right? So it's a user-defined type. Normally, so most classes are used as a blueprint to make objects. Right? And by used as a blueprint to make objects, I mean you can think of an object as being a copy, an independent copy of a class, more or less. It's not exactly true, but more or less you can think of it that way. Right? So when you make an object, you copy the class that it comes from. You make a new object, you make a new copy of the class that it comes from, and so on and so on and so on. Right? You might ask, why do we need to do this? Right? So why do I need individual objects? Right? And so if each object gets its own, is an independent copy of a class, that means whatever variables the class has, the individual objects also have their own copies. Right? So every object gets its own copy of all of the non-static fields or variables in a class. Right? And so we say that objects are allowed to have their own state. Right? And so the state of an object is simply the set of all the values of all of its non-static fields. Right? So for example, if you have a point2 object, right, where a point2 object represents a two-dimensional point, so it has an x-coordinate and a y-coordinate, right? You can create multiple points all having different x and y coordinates, and they're all independent from one another. And so here's a memory diagram of the 3 lines of code up here. So you use a class for the first program, right? So here we use point2 for the first time. What happens is the class gets loaded into memory. So the point2 class shows up somewhere in memory, right? Here I'm showing it at address 100. It doesn't matter where it is, right? It's somewhere in memory. If you look inside the point2 class, you'll see there's a variable called x, and you'll see there's a variable called y. Right? Every point has its own x and y coordinate. When you use new, new copies the class. So it makes a copy of point2, right, and plunks it down somewhere in memory. Right? So new allocates memory for one point2 object. And so for the first point, that's going to be that point there. Right? So we get some memory to plunk down a new point2 object. New calls the constructor for the class. Right? So this calls the constructor for point2 that sets the x and y coordinates to 1 and 2. Right? And so the constructor runs and fills in these two boxes here. Right? And now we have a newly initialized point2 object whose coordinates are 1 and 2. Right? New then returns a reference to this object back to whoever called new. Right? So the address 600 comes back and gets stored here beside P. Right? So that 600A simply means that P refers to the object at address 600. Right? The same thing happens for the next two lines of code. Right? New runs, so it copies the point2 class, plunks it down somewhere in memory. Right? Calls the constructor to fill in the coordinates of the point to -3 and 8. So you get a -3 here and an 8 here. Returns the address of the newly initialized point back to the caller. So that 700 goes back to the caller over here, and Q gets the value A. Right? And then the same thing happens for the third point there. Right? So call new 3 times, that creates 3 different objects in memory. Each point is independent of the other point. Right? If you change the x value, that x value and that x value don't change. Right? So you have 3 different points, all having their own independent state. And so the classes are what are called, what's going on with this microphone? Right, so many classes represent different kinds of values, right? So for example, a name, right? Or a first name and a last name or something like that, right? Dates are values, colors are values, points are values, right? From the Java standard library, a string would be considered a value class, right? Date would be considered a value class, right? An integer would be considered a value class. So when you go to implement these kinds of classes, to decide what information do they store and how are you going to, and how exactly are you going to store that information, right? So in other words, you need some sort of variables to hold the information belonging to the objects, right? The variables that represent the state of an object in Java are called fields. Right. Other programming languages use the word attributes or properties instead of fields. In Java, it's the term field is used. Right? But they all mean the same thing, variables that belong to an object. Oops, sorry. Right? So we're going to implement this point2 class. Right? So our point2, two-dimensional point. Right? So what does every point have? Well, it has an x and a y coordinate. Right? So what fields or what variables do I need to store the x and y coordinate? Well, the obvious answer is I need 2. Right? I need one field for the x coordinate. I need a second field for the y coordinate. There are other possibilities though, right? You could use an array of length 2. Right? So the first element of the array would be the x coordinate. The second element of the array would be the y coordinate. You could use a list of length 2. Okay. Again, the first element would be the x-coordinate, the second element would be the y-coordinate. Right? There's probably other representations that you can come up with as well. Right? But the most obvious one looks like this. Right? Oops, sorry. All right, so the class point called point2. So the first part here is the class declaration. Right? So this is where you name the class. Right? So here we've called it big P point2. Remember, all class names should begin with a capital letter. Right? Public means that the class point2 is visible to all other classes. Right? So anybody can use the class point2. When you go to add your variables or your class variables, or instance variables, I guess, to a class, most programmers put them at the top of the class. Right? So inside point2, we have our fields x and y. Right? They're of type double because we want to represent points having real coordinates, right? So int doesn't make sense, right? I guess float would be fine. I've decided to use double here. And notice that I've marked the fields as being private. So a private field is usable only inside the class itself. Right? So I can use the names x and y inside the class point2. Outside of the class point2, we can't see the variables x and y. Right? In general, unless you have reason otherwise, you should always mark your fields as being private. Right? If you decide later on that you need a different access modifier, you can change it later on. Right? But when you start, it's always a good idea to label things as being private. Right? Okay, so that class point2 is what's called a top-level class. Right? So a top-level class just means it's not inside of another class. Right? You look at the class point2, right? There's no other class here. So point2 must be a top-level class. When you go to pick your access modifier for a top-level class, you only have two choices. Right? So that word there is the access modifier. Right? So public means point2 is visible to everybody. If you get rid of the public, so you have no access modifier, then that's what's called package private access. And that means the class is visible only inside of the package it's declared in. Right? Let's do this in Eclipse very quickly. If it's open. Okay, so close that. Okay, so I'm going to put it in I'm going to make our different package. That doesn't matter right now. Right? So I'm just going to make the class point2. Right, so there's our class. I'm going to put the fields in, so they're private. Like that. Okay, so our class is currently public, so everybody can see it. Right? Our fields are private, so nobody or no class outside of point2 can see it. Right? I'm going to save that. I'm going to make another package, and I'm going to try to use the point2 class. Okay, so I've got the test package over here, and I'm going to make a little class called test. Right? I'm going to put in a little main method because I want to make a point2 object and try to do something with it. So let's make a point2 object and see if this works. So point2 p equals to point2. That. Okay, so Eclipse complains. Hover over the complaint, and it says that you need to import it. That's fine. You have to import it because it's in another package. Right? So that's fine. So import point2 from the package ECT. Right? And now Eclipse is happy. So that works. So the class point2 is visible from outside of the package itself. Right? If you go to the point2 class and strike public from the class declaration and save it, right? Test2 now doesn't compile. Right? If you hover over the import statement, it says that the class lect point2 is not visible. Right? So point2 is no longer visible outside the package that it's in. Right? And no other class outside the package can use it. Right? Inside the package lect2, though, point2 is in fact visible. So if I make another class also called also test, right? Put in a little main method. Right? Make a point2 object. Right? Everything's fine. Right? So from within the package itself, point2 is visible. Outside of the package, it's no longer visible. Right? And so that's the effect of the access modifier here. Now you might want to ask, so why would you use a package private class? Right? So why would you ever not put public here? Right? And so the answer is if you are implementing some class, that class needs help from another class. Right? So it needs help from a second class. Right? But that second class is not useful to anybody else. Right? It's only useful to the first class that you're implementing. Right? In that case, it makes sense to put both the classes in the same package and make the second class package private. Right? Nobody else needs to use the second class, right? But it is useful to other classes in the same package. And so Java offers you this, Java allows you to control the visibility of classes, unlike Python, right? So in Python, there are no visibility modifiers, but Java has them. What about the fields? Okay, so if the fields, if I make that field public, oops, sorry. Well, hang on, let me leave it private for now, and let's go try to do something with the fields. Okay, so in also test, so remember also test is in the same package as point2. I'm going to try to get the value of the x coordinate, like that, right? So to access the field of an object, right, you write p dot and then the name of the field, right? I happen to know that there's a field called x in the class point2, so I'm going to try to ask for p's x coordinate, right? And that doesn't work, right? You hover over the red line and it says the field point2x is not visible, right? It's not visible because it's marked as being private, right? So invisible outside of the class. If you don't put an access modifier in, right, the field now has package private access. So classes inside the same package as point2 can see x, right? Notice now also test compiles fine, right? There's no error now. Also test is in the same package as point2, so it can see the field x and it can access the field x directly by name. Right? There's another access modifier here called protected, which we'll see in more detail later. Right? So if I use the protected access modifier, the field is still visible inside of the package, right? So also test can still access p.x. It can still access x belonging to p directly by name, right? In addition to that, there are other classes outside of the package that can also access the field called x, but those classes are special, right? And we'll talk about those more later on when we talk about inheritance. And finally, you can label the field as being public. A public field is access to any class that can also see the point2 class, right? So as long as point2 is visible, public fields of point2 are also visible. So inside of test, which is inside of a different package, right, I can also now directly access the x coordinate of the point by name directly. Right? And so that's what the access modifiers do, right? They control the visibility of a field or class. Oops, come on. Right, so for your access modifiers on your fields, you're allowed to have 4 different access modifiers. Right, private, fields visible only inside the class that the field is declared in. Right, package private, the field is visible inside the class itself and inside the same package. Protected is the same as package private, but the fields are also visible to these things called subclasses. The subclasses can be in different packages. Public means the field is visible to all classes everywhere, as long as the class itself is also visible. Okay, so you might ask, so what access modifiers should I use for my fields, right? By default, they should always be private. If you have a constant that is useful to other classes, then you can mark those as public, right? So the class math has a public field called big I. It represents the mathematical value pi, right? That value is useful for other classes everywhere else. It's also a constant, so it can't change, and so it's safe to make it public, right? So in your assignment, your current assignment, if you're asking yourself, what access modifier should I put on my fields, they should be private, right? The last class that you implement has 2 constants. You should make the constants public. Okay, so that's the point2 class. Let's make another simple class. So I'd like to implement this counter class. So a counter class simply counts up starting from 0, right? So it remembers the count of something, right? Starts from 0, counts upwards, but in increments of 1, right? And so you ask yourself, oops, sorry, there's a lot of typos on these slides, sorry. It's because I copied and pasted a bunch of these slides. Okay, so what fields do you need to represent a counter? Well, it's just an integer count. So that's pretty straightforward, right? I just need an int of some kind. So there's the start of your counter class, right? So the counter class represents like a physical device that's used to incrementally count upwards from 0 up to integer max value, right? So the integer max value is a pretty big clue that you can just use int for your value, right? So the value, your field called value, that's just the current value of a counter object, right? So that's pretty straightforward. Stopwatch class. So stopwatch class is a little bit harder. So imagine you want to implement a class that lets you keep track of how much time has passed since you started the stopwatch, right? So it represents a physical stopwatch. There's a start button, there's a stop button, right? So you press start, the stopwatch starts keeping track of time, right? You press stop, it tells you how much time has elapsed between since you pressed the start button. Right? And so if you want to implement this kind of thing, you have to ask yourself, well, what do I need? Oh, sorry, another typo. Stopwatch. Right, so what fields do you need to represent a stopwatch? And so the answer is not obvious here because you don't know how to keep track of time. But it looks like you need a start time and a stop time of some kind. Right? Okay, so how do you get the time in Java? Right. And so there's many different ways to get the time in Java. If you're implementing a stopwatch, though, you probably want to keep track of time in seconds or something like that, right? You don't care that the current time is exactly 8:59 on Tuesday, January 30th, right? You just care that you know when you pressed the start button, right? And then similarly, you want to know when you pressed the stop button. And really what you want is how much time has elapsed between those 2 points. So the method called nanotime, which is in the system class, gives you the most precise time that's available on your computer. So the most precise time that your CPU makes available. Right. On a modern computer, that might be measured in units of nanoseconds, right? So 10 to the minus 9 seconds, right? Which is really, really small. It's not an absolute time, right? So this just returns some long value, right? You don't know what the long value means. It's just some value, right? But if you call it twice, so if you call nanotime once and remember the value, and you call it a second time and remember the value, you can subtract those 2 times to get the amount of time that has passed, right? So if you call nanotime to get the start time and store that value, and you call nanotime to get the stopping time and you store that value, you can simply subtract those 2 values to get the amount of time that has passed. Right? That'll be in nanoseconds. If you want your stopwatch to remember time in seconds, you have to scale that value up. Right? So for our stopwatch class, I've got the start time and the stop time. Right? Nanotime returns a long, so we're going to use a long value to store those values. Right? Now, you also need something else. Right? So your stopwatch, remember, you're going to press start, you're going to press stop, or that's the idea. Right? You need to know, is the watch actually running or not? Right? So has someone actually pressed stop? Has someone actually pressed the start button? Right? If they've pressed the start button, have they also pressed the stop button? Right? So if the watch is running, I want is running to be true. Right? Someone has pressed start, they haven't pressed stop. Right? If the watch is not running, then I want is running to be false, right? So either they've never pressed start, or they've pressed start and then they press stop without pressing start again. So you actually need a third field here to fully implement a stopwatch, right? And you can do lots of other examples of these simple types of classes, right? And so let's make another simple class. So let's make a class that represents a circle. So it's meant to represent the mathematical idea of a circle. Right? And so you ask yourself, well, what fields do I need to represent a circle? Right? And so number one, you probably need the radius. Right? So what type should I use to store the radius? It depends. Right? If you're implementing the class so that your circle has integer sizes, right, then you might use an int of some kind or a long. Right? If you want to implement the mathematical idea of a circle, you probably want to use something that represents real numbers, so you would use a double. Right? So let's do the mathematical idea of a circle, right? And you'd call it something like the radius. Right? Now, you need something else as well. Right? If you're keeping track of where the circle is, then you need the location of its center point. Right? Alternatively, you could keep the location of something else. Right? So if you imagine there's a square around your circle, you might keep track of the upper left corner, right, where that is, or the lower left corner, or the upper right corner, or the bottom right corner, right? It depends on the problem you're trying to solve, right? Arguably, you want to keep track of where the center coordinate is, right? So if it's a two-dimensional circle, the center point has two values, right? It has an x-coordinate and a y-coordinate. So you could do something like Cx and Cy. Oops, sorry. Right, and so I'm going to document these so that you know what they are. Right, so that's the radius. And this is the right? And Cx and Cy represents the center point of the circle, right? Is this the only way to do it? The answer is no, right? We've got this point 2 class, so instead of using Cx and Cy, so I'm going to call this implementation 1. Let's look at implementation 2. Right? I can use a point 2 object to represent the center point and just call that C. Right? Now the point 2 object takes care of managing the x and the y coordinate and whatever else you can do with points. Right? You can just ask the point 2 object to do that for you. Right? Which one is better? There's no better choice given that we don't know why we're using the circle class. Right? But they're both perfectly valid options. You wouldn't do both. Right? So a common mistake that new programmers make is that their fields are redundant, right? So there will be fields Cx and Cy, but there will also be a point C, right? And so now you're representing the, can you, right, so you have redundant fields here, right? You're representing the same information twice, right? Usually you don't want to do that, right? Now that you're representing the same information twice, every time you change one of the pieces of information, so suppose I change Cx, I have to now remember to also change C, and that's really inconvenient, and it's really easy to forget to change both fields, right? And so you generally want to avoid a redundant representation. Sometimes it's useful, right? Here it's not. Are there other implementations? Sure there are, right? Implementation 3, private, double, C. Oops, sorry, not like that. Right? So just like for the point 2 class, private, sorry, right? So just like for the point 2 class, is it complaining about that too? Delete this token, private. Like that, sorry. You can't specify the size, my bad, right? So just like for the point 2 class, instead of using two separate fields, Cx and Cy, right, that are two doubles, you could use an array, right, and store the coordinates of the center point in the array, right? If you really wanted to, right, you could store everything in the array. So private, double, so I want the radius and the center point, right? So I have to give it a name. What's a good name for this? Data? Right, so data 0 is the radius, data 1, x-coordinate of the center point, right, and data 2 is the y-coordinate of the center point. Right, and so on, and so on, and so on, and so on, right? You keep on going, right? And so which is the best choice? You don't know, right? It depends on why you're implementing this class, what are you using it for, right? And many other things, right? So because we don't actually know what we're using this class for, there's really no good reason to pick any one of these over any of the others, right? Arguably, though, that's probably the easiest to understand, right? So in this course, you're never going to be, well, never is a strong word. In this course, you probably won't be asked a question like, pick the best representation for this class, right? So you'll be given some sort of problem description, say, what is the best representation of this? There probably isn't a best, right? Or you could argue that many alternative implementations are equally as good, right? So as a new Java programmers or new object-oriented programmers, right, you should pick the representation that is the most obvious to you. As you gain experience, you'll realize that differences in the choice of your fields affects how you implement the class, right? And so your choice of fields can make your job harder or easier when you go to implement the actual constructors and methods of your class, right? But you won't actually know what choices make the implementation harder or easier without experience, right? And being a 12-week university course, you're not going to acquire that much experience in this course. Right? And so you shouldn't worry too much, right? So don't worry about optimizing your choice of fields in this course, right? But pick sensible fields for your objects, or for your classes when you're asked to implement a class, right? Avoid redundant representations, right? So don't put all of these in the same class, right? That doesn't make any sense, right? Pick one of them and go from there and see what happens. Okay, so in our current form, the classes are, believe it or not, usable, right? So you can make a point-to object, you can make a counter object, you can make a stopwatch object, right? Even though we haven't defined any constructors in our classes, right? There's nothing in our point-to class, right? So if you go to point-to, there's nothing here, right? But you can write new point-to, right? If the field is public, you can access the field. All right, so if you want to make this thing usable, right, so right now it's not usable, you want to add some methods to your class, right? So for example, if you're implementing the stopwatch class, right, you probably want a start method that starts the stopwatch. You probably want a stop method that stops the stopwatch, right? If you're implementing the point-to class, you probably want to let people know what is the x coordinate of the point, what is the y coordinate of the point. Can you change the x coordinate of the point? Can you change the y coordinate of the point? And so on and so on and so forth, right? So our classes have fields, so they have data, right? We now want to add methods, right, or operations or behavior to our classes, right? And so in object-oriented programming, the term encapsulation, right, refers to the bundling of data and methods together into a single unit, right? So classes are a form of encapsulation in Java. Right? They group the data belonging to an object and methods that operate on the object into one place. Right. Constructors are the first thing we're going to implement, so we're going to provide some constructors that let users of the class initialize our objects to some well-defined value. Right? This is worth memorizing. Right? The purpose of a constructor is to initialize the state of an object. Right? It should set the values of all non-static fields to appropriate values, right? When you make a point-to object, you should not set the coordinates of the point-to to some random values, right? Unless you implement a constructor that explicitly does so, right? You probably want to set the values of the fields of your objects to some well-defined values, right? When you implement a constructor, right, it always has the exact same name as your class. It never returns a value, right? It's allowed to have zero or more methods. So constructors look like methods. They're not methods. They don't return anything, right? Whenever you use new, you have to call the constructor, right? So the purpose of the constructor is to initialize the object, right? If your class has no constructors in it, Java makes one for you, right? So it sticks in the no argument constructor for you. What is the no argument constructor? It's the constructor that has no arguments, right? So it has 0 parameters, right? What is it supposed to do? It's supposed to initialize the state of an object, right? So if the caller is not passing in any information about the state, as the person writing the class, you have to choose what is a sensible state for your object, right? If you don't implement if you provide no constructors for your class and you just use the compiler-generated one, right? What the compiler-generated constructor does is it sets all numeric fields to 0. It sets any Boolean fields to false. If you have any reference fields, it sets them to null, right? So that's what the no argument, that's what the compiler-created no argument constructor will do, right? If you're implementing more than one constructor in the class and you want a no argument constructor, you have to define the no argument constructor yourself, right? So you only get the no argument constructor for free if you have no constructors. As soon as you put one in, you don't get the no argument constructor for free. So we're going to have multiple constructors. We have to provide our own version of the no argument constructor, right? So what should the point2 constructor look like? Well, I guess a sensible default point is the point 0, 0. You could choose something else. You could choose 1, 1, for example, or something else, right? 0, 0 seems to be the most sensible to me. That's the no argument constructor, right? So name of the constructor matches the name of the class. No argument constructor, so there's no parameters for the constructor, right? So it's the empty round brackets, right? Just like the class, you're allowed to put an access modifier on the constructor, right? So public means any class that can see point2 can also use the point2 constructor, right? What should the constructor do? It should set x and y for the point to equal 0, right? Now, the question that you have to ask yourself is, what point is it supposed to set the x and y coordinate for, right? So when you call the constructor, one of the pieces of information that the constructor gets is the object that was used, or the object that new just created, right? So remember, new makes an object, right? New tells the constructor which object is being initialized. It gives that object a name. It calls it this, right? So when you see the word this inside of a class or inside of a method or constructor, right? That word this means, inside the constructor, it means the object that is currently being initialized, right? So it's a reference or a name for the object that's currently being initialized, right? So whose x coordinate do I want to set? Well, I want to set the coordinate of the object being initialized to 0. Whose y coordinate do I want to set? I want to set the object who's currently being initialized to 0, right? So this dot x, this dot y, both equal 0, right? If you go into Eclipse and put in the constructor, public, right? Like that, right? You'll find that if you forget to put in this, Eclipse is also happy with it, is perfectly happy with that as well, right? So Eclipse also says that this is acceptable, right? Doesn't warn you that there's an error or anything. It says this is fine, right? So if you use a field inside of a class and you don't write this dot in front of it, the compiler automatically inserts this dot for you, right? And so many Java programmers will not use this dot when they access a field inside of a class, right? In this particular case, it's fine, right? X equals 0 or this dot x equals 0, they both mean the exact same thing, right? Many programmers will say that this dot just gets in the way, right? It clutters your code, makes it harder to read, right? Other programmers will argue that writing this dot makes it clear that you're accessing a field, right, and not something else, right? I'm always going to write this dot in front of it whenever I access a field, right? That's only to emphasize the fact that we're accessing the field of an object. For the purposes of this course, it doesn't matter whether you write this dot in front of it or not, right? Unless you have to. So there is a situation where you have to write this dot in front of it. So there's your constructor, right? Now, what happens when you run a constructor, right? So you run a constructor when you call new. So new point2 makes a point2 object somewhere, right? It copies the class, right? So somewhere in memory, a reference variable p gets created, right? New allocates memory for the point2 object. So it copies the point2 class. It's going to plunk it down right here. It's going to plunk it down right here, right? So it copies the point2 class, makes a copy of the class, right? What's inside the class? Well, there's a variable called x and there's a variable called y. So every point2 object gets its own x and y, right? The point2 constructor runs, right? When it runs, new tells it the address of the object that's being created, right? So new tells the constructor, hey, the object at address 600, it's being initialized, right? So the constructor runs somewhere in memory, right? The constructor knows the value of this, right? It's 600A, right? The address of the object being initialized. What does the constructor do? It says this dot x equals 0, right? What does this dot x mean? It means this, so object at address 600 dot x, so the field x gets the value 0, right? This dot y gets the value 0. So this object at address 600, its y field gets the value 0, right? Constructor finishes running. New finishes running, returns the address of the object back to the caller, right? So the reference p gets set to the value 600a, right? So in other words, the variable p refers to the object at address 600, right? That object was just initialized by the constructor that ran here. Right. What about the counter class? Okay, so no argument constructor for the counter class, right? Name of the constructor, same as name of the class. No argument constructor, so round brackets, no parameter, right? Public, because we want everybody to be able to use the constructor, right? What should the constructor do? It should set value, right? What should the no argument constructor set value to? Well, for a counter, it probably also makes sense to set it to 0, right? The current count is 0, right? So this dot value equals 0, or in this case, value equals 0, right? They both work. One more time, just to make sure you've got this clear, right? When you make a counter object, or when you call the constructor, right, and create a variable, right? So the variable c gets created somewhere in memory, right? New runs, so it allocates memory for the counter object, and it copies the counter class into the newly created object, right? What's inside the counter class? Well, there's this variable called value. So every object gets a field called value, right? The counter constructor runs. It gets the address of the newly created object. So the constructor is going to run knowing that the object is at address 550, right? So there's our point2 constructor, right? One of its parameters is this, right? And it gets the value 550A, right? It does this dot value equals 0. So this, that object there, dot value, that field there, gets the value 0, right? The constructor finishes running, new finishes running, returns the address of the object back to the caller, right? And so that's what happens. That one line of code there causes a whole sequence of events to happen here, right? And there's actually a hidden sequence of events in step 3 that you'll learn about in a few weeks. All right, so that's all that we have for today. We'll pick this up, I guess, tomorrow.